SAFE Software is pleased to present the 2009 FME International User Conference. This session is presented by Ted Norcott of Terasen Gas and Tom Welsh of Ubisense. Ted is a GIS specialist and has more than 16 years of experience in the GIS field. He has been using FME for the past 13 years and specializes in data translation and conversion, as well as cartographic design and production. Tom is a senior consultant with Ubisense and has been involved with the support, development, and implementation of Smallworld GIS products since 2001.
Okay, thank you everybody for coming. We'll just start off, just give you a little background about Terasen Gas. The company was formed in 1988. We are now a subsidiary of Fortis. We had a few ownership changes over the years. We're a regulated natural gas distribution company, and we service coastal and interior areas of British Columbia, including Whistler. You might see some of our staff around. They've got the Terasen logos on. They're doing a Whistler conversion project right now. Not data conversion though, but we have approximately 930,000 customers, 1,200 employees, and we operate 48,000 kilometers of pipe. And we also have the distinction of being, or having the largest territory of any North American gas utility. This gives you a little overview of our service area. We're quite extensive. We're broken down into 3 regions. So first we have the mainland gas region, which would be the lower mainland, Fraser Valley, as well as the interior and Columbia Kootenays areas of BC. We also service Vancouver Island and the Sunshine Coast, which is shown here. And Whistler, which actually, as I mentioned, is undergoing conversion from propane to natural gas. So this line here represents our new pipeline, which is supplying Whistler. So getting back to the mapping. In 1980, CAD was introduced, so we went from the cave drawings to digital mapping, and in 1999, Smallworld GIS was launched. And over the years, we've had numerous customization changes. We've had data model changes, version upgrades. We've had the ISIS warping project. Is Ken Rigler in the room? Ken, there's your plug. So we're about 50% through the province in terms of warping our data. And in 2007, that's when we launched our FME SpatialDirect, which was a big step for us as a company. So a little bit about SpatialDirect for those of you that may not have used it or are going to be possibly moving directly into FME Server. FME SpatialDirect uses mapping files. So for those of you that have been using FME as long as me, you know how difficult and cumbersome it can be to work with those. But of course, this opened the door for FME for the non-GIS user. It increased the availability of our GIS specialists. There's only 2 of us in the entire company, and we have about 17 drafters that at the time were using SpatialDirect quite heavily and still are using it, but now as FME Server. And at the time, this provided us with new capabilities. We could now do file sharing with clients, and it also formed a platform for the future. Now we've now moved into the next generation of SpatialDirect, FME Server. In order to use FME Server, you need a plugin called Spatial Biz. I just wanted to mention that because without that plugin, there's no communication between FME and Smallworld. Another big change is that we've moved away from mapping files. We're now using FME Workspaces, which as you guys have seen and know, a much easier way to create your data translation files. Which I'm going to talk in a moment here about the Schema Mapper lookup table. That's a big component of our FME Server upgrade. And on top of that, there's something now called Publish Parameters in FME Server. So in other words, we can now select the alternative that we want to download from. Prior to that, we were stuck with only downloading from the top alternative. So now the user can dynamically select the alternative that they want, as well as the projection and the datum that they're interested in. And then the last point here is the Smallworld integration, which is what Tom's going to be talking about briefly. So a little bit more about the Spatial Biz Plug-in. It's fully aligned with the FME product. It works with Universal Translator, Workbench, and the viewer, and supports bulk retrieval of Smallworld data. Now this is a sample workspace. In particular, this one here, we've got approximately 102 Smallworld objects on the left here. And this workspace here is actually an example of a translation which we're going from Smallworld over to MicroStation format. So since we have such a large number of objects on the left here, this is actually advised to us by Mark Stokes to actually filter these or funnel these into a sampler just to make the workspace a little tidier. So that's what that first translator is doing. And then from here, of course, the next step is we need to clip the area of interest. And Tom's going to go into a bit more detail about this, but what's happening here is we have 4 parameter fetchers, which are basically grabbing the bounding box for the area of interest. And then that is then being converted into a 2D, two-dimensional box, which will become our clipper, or our clip bounds. Okay, so basically we have that 2D box, which is then flowing in to become our clipper, and then we have all of our Smallworld objects, which are now becoming the clip-E. The next step is the schema mapper. And this is just a sample of what our schema mapper file looks like. There are approximately 378 map features, but I just wanted to show you a few here. In this example, we have the anode object, and so this is coming from Smallworld, the Smallworld GIS data store, and from here we're defining the status here. So we've got status attribute. The status here, there's 5 different status types. We are then defining the MicroStation level. So in this case, we have 4 different levels that we want to map out to. And we also have to define the MicroStation cell name, which in this case is mag anode. And there's a couple other attributes here for rotation adjustment and the type of object, which is a IGDS shared cell. Okay, so that's the schema mapper file. And this is quite detailed. I'll just quickly go through what's happening here. So the schema mapper file is being read at this point, and then there's quite a few things happening here. We have the bi-level attribute creator. We have a couple more attribute exposers, etc. But basically what these are doing is they are fine-tuning that schema mapper file depending on the type of output we want. In other words, we have different scales that we're dealing with. So our standard scale is 1 to 1,000, but we also want to output at 1 to 250 and 1 to 500, and even 1 to 750. So these are sort of fine-tuning that schema mapper, and then all the data is then flowing into a generic IGDS object, which is then being fanned out by the MicroStation level. So rather than having, as we have here, 378 feature levels, it's nicely packaged into that generic level, or that generic MicroStation feature, which is then fanned out by the level, if that makes sense. And if any of you want a copy of this workspace, I'd be more than happy to give you a copy so you could have a look at it. So those are being sent out to the 378 levels. And just wanted to show you, so this is an example of what you would see in our Smallworld database. So this is actually the hotel. The hotel isn't there, but these are the pipelines around the Weston as it appears in our GIS system. And then this is the resulting MicroStation output. So it's quite, I find anytime I see a black background, it usually indicates a CAD file. So other than that, though, the data is identical data. So I'll hand it over to Tom, and he's going to share with you the Smallworld end of this project.
Thanks, Ted. Well, my name's Tom Welsh, and I've been doing support with Terasen on their AM/FM system, which is their Smallworld system. And so what we're looking at here is providing a simple user interface for the Smallworld users at Terasen. They're not necessarily GIS specialists like Ted, but they're familiar with using the Smallworld system. So we wanted to give them an interface that they're familiar with, lets them perform their FME translations or submit them to the FME server in a really user-friendly way. So we developed this interface here, and it really relies on three key pieces of software. The first is obviously FME server. The second is obviously Smallworld. And then the third, as Ted had mentioned, is the Spatial Biz Plug-in from Spatial Business Solutions, which is a module built on top of Smallworld, and it's loaded in with the Smallworld product when you have it from Spatial Biz. So what we have here is we've got our client desktop that the user's on, which is running Smallworld, so they're connected to the Smallworld server and seeing the Smallworld data stores. They have the FME server menu also loaded, which is a module within Smallworld that we've developed, and it's activated. Now the FME server menu can see the FME server environment where we have our FME workspaces in a repository. And we have a number of these. Ted might know exactly how many there are, but somewhere around 10 or so. And the FME server menu lets us essentially select one of these workspaces to set up a translation. Here we simply pick from the repository which construction drawing extract or which workspace we're interested in. Now these workspace files, if you open them up in Notepad, you'll see that they're just a simple text file really. And so it makes it quite easy to parse this in the Magic Smallworld environment. So we parse that out and we get all of our default parameters. And then we can use this tool to set the parameters differently if we'd like. We've got our workspace name. We have the output coordinate system that we're using. Now we have the alternative. Now this is where the Spatial Biz plugin is really nice because it will move into a different alternative of the Smallworld data set on a different server and allow extraction of data within whatever alternative you specify. Now, unfortunately, at this point, we've only got one alternative name here, and you can have multiple data sets. So this is a limitation for us right now. You have to specify an alternative that exists in both or however many data sets you have. It has to be the same alternative, otherwise it will default to top. And then down below here, we have our themes or our actual objects or RWOs. And we can select which objects and which geometry types we want to set up for the translation. Now, as Ted mentioned, we're using an area to clip the data. We don't want to extract all the data, obviously, and just get bogged down. We want just a certain area. So the way we've designed this is we use the bounds of the current map view within Smallworld. And then we calculate the width and the height and the other parameters needed to calculate those clip bounds in the workspace. Now we can save this information off. Instead of just running it, we built in the ability to save this to an HTML file. Down here we're calling it 1 to 250 HTML. This is basically what that HTML file looks like. And what you can see is it's just a simple form that's automatically submitted. We have here the path to the FME server, which you can see the server name up here, FVAMFMP04. And we also specify the workspace that we're using, the FMW file. And then we see all of our parameters here that are published. The min X, min Y, width and height for our bounding box, as well as the feature types or our themes. We also have our coordinate system and all our alternative name. Now, just kind of going over an overview of what we've looked at here. We've got our client desktop, which is running Smallworld with the FME server menu. So it's contacting the data stores on the Smallworld server. It's also contacting the FME workspace over on the FME server. And it's using that information to create an HTML file, or the FME server request. So if we're starting from scratch from our FME server, we can load in previously saved HTML files. And now we have all of the parameters that we've previously set up. And we can now run the request, actually send the translation request off to the FME server. Alternatively, instead of coming into Smallworld and using this menu, we can just open up the HTML file in Explorer, and it's going to automatically submit that form, and we can skip this whole stage. So this is basically primarily for setting up these translation requests. A number of users that maybe aren't too savvy with the GIS environment, a few people can set up all their requests that they want, email them their HTML files, say you run these whenever you want, as long as you are on a computer that has access to the FME server by the network, you're good. You don't even need to be within Smallworld, because Smallworld's also going to be accessed by the FME server itself. So we run that HTML file, or just open it up in Explorer. We get this very fancy splash screen here. You can see we haven't put too much time into developing a nice splash screen. And and always, of course, it succeeds. And we get our zipped file of our, in this case, MicroStation results. So what happened here? Our HTML file, or our FME server request, went over to the FME server itself. Now I say FME server, and we see the application FME server. I mean the FME server environment. It's the box that it's sitting on, which is running the FME server product, which has the Workspace repository, including the one that we've specifically referenced in our HTML file. Now it's also running Smallworld with the Spatial Biz FME plugin. The way we do this is we have a service that we set up on the FME server that automatically launches Smallworld, loads in the Spatial Biz module, and then sits there running, waiting for the requests. And then obviously the FME server here is accessing the data stores on the Smallworld server. And then with their requests, we get our zipped results. And that's basically it. I'll hand it back over to Ted here.
Thanks, Tom. Okay, so we'll just go over the benefits that we've seen already. First one being deployment of Smallworld data to clients in multiple scales and formats, as you saw. There's quite a variety at this point, which we want to, of course, improve on. This increases the flexibility for the drafters, as well as myself and my colleague who's a GIS specialist. It's been, I'm telling you, much easier to enhance and maintain on a regular basis versus the old mapping files. In fact, took so much time to just get your head wrapped around the mapping files that we ended up handing it over to a consultant that could spend more time on a daily basis to do that. So now, because we're using Workbench on a regular basis at the desktop level, to move from the desktop over to the server is virtually seamless in terms of how the tools work, which is great. It's provided us a more stable environment. In the old, under the old FME SpatialDirect, we had it actually sitting on a standalone workstation. So now we actually have a proper server environment. And as I mentioned earlier, the third-party data sharing is another big bonus for us. So in the future, we want more formats. Difficulty is finding the time to be able to work on these, but it's definitely it's there. We just have to spend the time to do it. Next, another step would be to extend access to other Terasen departments, and in the future provide some limited public access, maybe even to ISIS. Maybe they'd be able to download data directly into their system as well. Okay, thanks a lot.